Okay, good morning. So, today I will discuss another very important cyclic compound called cyclodextrin. Cyclodextrin. Okay. There are specifically three cyclodextrins are very important: alpha, beta and gamma cyclodextrins. Now, photosynthesis by plants, they produce glucose polymers. So, plants produce glucose polymers. From plants, we can get glucose polymers 2. Glucose polymers. What are these glucose polymers? These glucose polymers, one is called cellulose, while the second one is called starch. Now, cellulose is an insoluble material that is used in resistant and structure forming component in the cell. Like in a tree, the outer part is made of cellulose, all right, and the starch is convertible energy source. Starch is convertible energy source. We are interested in this starch. Now, starch has two polymers. Starch has two polymers. Starch has two polymers. One is several thousand D glucopyranoside, glucopyranoside units linked by linked by 1,4 glycosidic linkages. Okay. While the other both 1,4 and 1,6 glycosidic linkages. So, this is what happened. So, from starch we get two polymers. One is 1,4 with 1,4 glycosidic linkages, and the other is both 1,4 and 1,6 glycosidic linkages. All right. Now, these polymers can be degraded by various means, by acid treatment, by heat, by ionizing radiation, in presence of water to form a mixture of degradation products, called dextrins. So, here we are, plant produces cellulose and starch. Out of that, starch is a convertible energy source, and starch on its own has two types of polymers. One has 1,4-glycosidic linkages, and the other has both 1,4 and 1,6-glycosidic linkages. So, these polymers can be degraded to dextrins by heat, acid, ionizing radiation, and so on. Okay. These dextrins are very important compounds. They are produced in large quantities industrially by this ionizing radiation and etc., etc. Okay. Because they have various industrial applications. They are used in cosmetics, used as food items, and so on. Big industries is there. However, when starch is degraded, so this is the situation. Now, I degrade starch with enzymatically. Starch I degrade by CGT enzyme, cyclic enzyme glycotransferase. Without, it does not require any water. So, this glycotransferase enzyme, it can be also degraded where the primary products are cyclic. Primary products are cyclic 1,4 linked compounds called cyclodextrins. Okay. So, we take starch and degrade it with glycotransferase enzyme. It does not require water. So, it gives cyclic 1,4 linked compounds called cyclodextrins. So, these are the primary products. Okay. These are the primary cyclodextrins are the primary products. Some linear molecules are also formed. So, let us show it this way. So, okay. What I have done here is a starch polymer, starch, and to starch, this is starch. This starch we apply CGT enzyme, you apply CGT enzyme and you get cyclic compound, some linear, cyclic compound, linear, again cyclic. So, a mixture of product, mostly cyclic, linear, cyclic, linear, cyclic, linear, cyclic. Okay. So, these are cyclic and acyclic dextrins. We take starch and then apply CGT enzyme, and it will be again cut into many pieces, where you get both cyclic and acyclic dextrins. These cyclodextrins are important for us. These these cyclic compounds are called cyclodextrins. So, these cyclic compounds are cyclodextrins. These cyclic compounds are cyclodextrins. So, let me draw a picture of cyclodextrin. It will take a while, nevertheless, I will attempt. Okay. So, it may not be the world's greatest drawing, but still I am going to do it. Maybe little bit more this way and this way. Okay. So, here it comes OH, here it comes OH. Okay. Then I go, I draw this. Okay. This primary alcoholic group, secondary alcoholic groups. At least one is necessary to draw. That is why I am taking trouble so much to draw it. I am not going to draw all 6, it will take hell of a time. However, nevertheless, I will draw some. Okay. Then all right, hang on. O, then I can get, hang on, I will get it. OH, 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 okay. So, with lots of difficulty I could draw 3. If I could draw 7 and it will be a, let me draw a cartoon, fine. So, I can get 1, 2, 3, 4, 5, 6, 7, then that will be beta cyclodextrin. In short, we say beta CD, okay. And if there are 6, we call alpha CD, and 8 we call gamma CD. So, this is a cyclodextrin, and what is 1,4 linkage? So, this linkage is, this is 1, this is 1. So, is a linked through 1, 1, 2, 3, 4. So, 1,4 linked throughout, 1, 2, 3, 4, okay. So, 1,4 linked, these are all 1,4 linked, okay, and they are cyclic. So, that is why they are known as cyclodextrin. This particular one, when it is 7, we call it beta cyclodextrin. Similarly, we have alpha, we have gamma. How this molecule look? This molecule is not planar, okay, but it has a 3-dimensional structure. How? It is look like this. Let me draw all this. So, let me draw. Okay. Now, okay. Okay, and is outside. So, it looks somewhat conical shape, and alpha is all are in angstrom, okay, 5.7 angstrom inside, and outside is 13.7 angstrom, okay. So, it is 5.7 angstrom and outside 13.7 angstrom. Let me draw the another one. I will not draw all 3, but another one. Okay. So, another one is say 15.3 angstrom. These are all angstrom. I do not have space to write, and this is 7.8. 7.8 angstrom, this is 15.3 angstrom. Okay. And what is the depth? Depth is from here to here is 7.8 angstrom. Okay. 7.8 angstrom. All right. 7.8 angstrom when it is gamma. Okay. So, maybe I make sure. All right. So, what happens? These molecules are cyclic and they are like a conical shape with open ended on both sides. Open ended on both sides, and what is this side? This side has the primary hydroxyl group, that is CH2OH groups. These are CH2OH groups, and here is OH groups, they are outside. So, that means OH groups and CH2OH groups. Okay. So, these OH groups can be functionalized. We can functionalize and we can add something. Okay. We can add, say I can mono substitute it to make a particular for a particular job. What kind of job? This inside is hydrophobic in nature. So, therefore, a molecule, if you take a molecule, okay, or my substrate, suppose I want to cut a bond, specifically cut a bond, okay, then what will happen? I can put that compound together, okay, stir it, that molecule will go inside. For example, say aromatic, all right. Let me write here, say aromatic. So, aromatic goes here and the other part is outside, other part is outside here. So, this outside part will react with either OH, it can react, or a suitable substituent X. I can put X here, they come very close, they make weak bonding, come very close, and thereby they can react, all right. They can easily react and give rise to the formation of products. So, this is called supramolecular catalysis. We can do supramolecular catalysis with this kind of with cyclodextrins. And why they are so important? Because they can be easily obtained from plant, all right. These cyclic sugars can be obtained from plants. We take starch, isolate starch from plant and then apply CGT, and once we get CGT, apply CGT, we can get this cyclodextrin. We separate them because their sizes are little bit different, and after we do that, we can derivatize it. We can derivatize these OH groups and allow a reaction to happen, because if the OH groups are here and my compound is inside is happily. So, it is like a you bring your reagent very close to this reaction sites, and if they are very close, they will react immediately. Okay. They will react immediately, they will react, and you will get the product. This is one example. Because there are many examples with cyclodextrin, I will try to do. So, therefore, this is hydrophobic. This is a hydrophobic interior, hydrophobic, and at the end is hydrophilic. Hydrophilic, here is also hydrophilic. The presence of OH groups makes it hydrophilic. Okay. So, these are hydrophilic, and interior is hydrophobic. This is a primary alcohol and these are secondary alcohol here top, which are more reactive, and then I can easily get things done. So, this is cyclodextrin, and they are very important because they are quite cheap. We can easily get it from plant kingdom. So, therefore, we learned, and when we compare with cucurbituryl are what? Cucurbituryl also, but they are very difficult to synthesize and will be much more expensive. So, they are like this, cucurbituryl, they are like pumpkin shape. So, there is a similarity in structures, architecture of hydrophobic. So, this is also hydrophobic, and at the two ends are hydrophilic, similar to cyclodextrin. Inside is hydrophobic, and at the two ends we have hydrophilic moieties, and so suitably we can get our reactions done. So, this is about cyclodextrins. And you might be wondering why I am talking about so many different things. Okay? So many different things. These are because these species, we can use them in different supramolecular situations, okay? Making devices, making causing catalysis, so on and so forth. All right. So, I have completed these cyclic products, cyclic compounds, how they can be synthesized, so on and so forth. One day I am going to give you reference of all that, but I can say on the top of my head there is a reference, good reference, you can say comprehensive supramolecular chemistry. Comprehensive supramolecular chemistry by a large number of groups, okay, across the world. They contributed, and it is published by the first one was published by Pergamon Press. Okay, and so this book will give you how to synthesis of all these compounds that I have discussed so far. So, next time what I will be doing next time in the next class, I will be discussing what is called dendrimers. Okay, and then we proceed. we are going more and more to complex systems as we move. Thank you very much.